Wow.
Good.
Well, no, don't worry. I'll lead you in, buddy. I'm just waiting for it to tell me it's live.
All right, okay. Good morning.
Sometimes it starts on time, sometimes it doesn't. So we're trying to cut it closer to the 20 minutes so people get to not just the part of us just riff-raffing. Yep, Niche, for some reason it doesn't want to open. So
it is live.
You're joking me.
No, just now.
Okay, great. Welcome. Hello, and a very warm welcome back to the Streaming School. I hope you're enjoying the lesson so far. Please remember that you can access all the previous lessons when we're covering a range of subjects. The website and the link on the social media will give you more information about who we are and what we're trying to do. But essentially, we're just helping parents and some teachers out with some continuity on delivering different items to you during the lockdown period. And lucky today to have Mr. Sam Winch with us. A very good morning to you, Sam.
Morning, guys. How's everyone?
Yeah, really well, buddy. How are you?
Good.
Yeah, good. Thank you. Great weekend. Probably a little bit too much chocolate, but yeah, maybe a run after this, I think, today.
Did you catch a little bit of sun in the garden?
Oh, yeah, lots of sun Friday, Saturday. Obviously, barbecues in the garden. And yeah, today, one run, of course, no more than one, sorry. One run today, maybe even a cycle tomorrow as well.
Wonderful, wonderful. Well, I'll even venture outside. I don't think I've left for about a month. I literally don't think I've gone anywhere. So not even for that daily exercise we're allowed. So without further ado, buddy, we'll turn it on to how's that mathematically? If Leon does 0 exercise and goes outside 0 times, how many calories can Leon consume in a day? I'm sure you're going to do something more intelligent and complex at that. So we've gone to your screen, buddy, and just let us know if and when you want us to change back.
Yeah, brilliant. Cheers, Leon. Cheers, Nish. Well, so I'll introduce today. Today we're going to be looking at ratio, and we'll go into more detail on ratio in a little bit. But to start off with, we're going to recap some standard form because I'm aware that on Friday we might have rushed through the last little bit, which is addition, subtraction, multiplying, and dividing with standard form. So that's what we're going to start off with today. Nish, if you can share my screen, please.
All good.
Brilliant. So as you can see on the screen, I've got my trusty pointer. Here's a quick recap of how we add and subtract standard form and then multiply and divide. So we start off by adding and subtracting. You look to convert the numbers from standard form into decimal form or ordinary numbers. And I'll give you some examples in a short while. You complete the calculation and then convert the answer back into standard form. So obviously we worked on how to convert into standard form and how you convert from standard form. We're going to be looking at that, and then we're going to do the sum of the question, and then go convert it back into standard form. Multiply and dividing, similar. You're going to multiply or divide the first numbers, and then apply the laws of indices to the powers of 10. So there'll be a couple of examples on the screen coming up. Here we've got question 1, which is 8.5 times 10 to the power of 0. Well, of course, we know that 10 to the power of 0 is 1. So in effect, 8.5 times 1, which is still 8.5. And then that's subtract by 4.5 times 10 to the power of minus 1. 10 to the power of minus 1, we know it as 0.1. So 0.5 times 0.1 would give us 0.45. And then we're looking to just subtract 8.5 subtracted by 0.45, which would give you 8.05. Of course, in standard form, it's just 8.05 times 10 to the power of 0. Over here, we've got 2, we can addition here, 2 times 10 to the power of 0, which just gives us 2, because we know that 10 to the power of 0 is 1. So 2, add 7 times 10 to the power of 1. 10 to the power of 1 we know as 10. 7 times 10, of course, is 70. So what's 2? That's 70. Nice and easy, we've got 72. If we can convert that back into standard form, 72, of course, remember, standard form has to be between 1 and 10. So how can you convert 72 between 1 and 10? We change it to 7.2. So the answer will be 7.2 times 10 to the power of 1. Okay. Then looking at multiplying and dividing. Here you've got question 6 with 7 times 10 to the power of 2. 10 to the power of 2, we know that as 100. What's 7 times 100? Of course, you've got 700. and that's multiplied by 2 times 10 to the power of 2, or also known as 10 squared, and that gives us 200. The question then we've got is 700 times 200, which gives you 140,000, which would give you 1.4 times 10 to the power of 1, 2, 3, 4, 5. 1.4 times 10 to the power of 5. And then final example is 14. 8 times 10 to the power of 1. And we're looking to divide that by 8 times 10 to the power of 0. 8 times 10 is 80. And here we've got 8 on its own. So 8 times 1, in effect, is 8. So 80 divided by 8, we know that is 10. But we're not going to write it as 10 in standard form. And remember, it has to be between 1 and 10. So we'd have to write it as 1 times 10 to the power of 1. Okay, so I hope that's a few examples for you there. I'm just going to do a couple more with my trusty visualizer. And I'm going to give you a couple of examples on the board here. So we'll start off with this first one where we've got 6.5 times 10 to the power of minus 2. Take away 8.5 times 10 to the power of 0. Power of the dot. Now, what we're going to do here, if we write it out as an ordinary number, so we know it as 0.065. I hope you can see my pen nice and clearly there. We're going to flip them upside down. The reason why is because we're going to get a top-heavy number. We're going to get a minus number, is what I want to say. So we've got 8.5 on top. And then all we have to do there is subtract. So 6.5 times 10 to the power of minus 2 as an ordinary number is 0.065. And then, of course, we're just going to subtract. Now, they say 0 take away 5 you can't do. Hopefully, later on in the next few weeks, I'm going to show you a couple of ways to do long subtraction, because there's a couple of cool methods. When they say 0 take away 5 you can't do, well, you can, it's minus 5. But I'm going to show you that method in another day. What we're going to do is the traditional method of borrowing. So we've got 10 take away 5, which is 5, 9 take away 6, which is 3, 4 take away 0, which of course is 4, dot and dot, so there's your decimal point, and then 8 take away 0 is 8. So the answer to the first example will be 8.435. Because we swap them over, it has to be minus 8.435. Okay, that's quite a tricky one to start off with. There you'll be looking at around a grade 4 to 5, which would be a crossover on both the foundation and the higher paper. Okay. Again here, so we've got 5.5 times 10 to the power of minus 1 as an ordinary number. We know that as 0.55. And then we're just looking to add 3 times 10 to the power of minus 3, which gives us 0.003. Addition, nice and easy. There's nothing there we can add, so we could just put a 0 if that helps. And of course, we've got the 0 at 3, which is 3. 5 at 0, 5 at 0, decimal point, and 0. Okay, so the answer there is 0.553. That's the answer as a ordinary number. To convert it into standard form, I want you to write it down as 5.53 times 10 to the power of what? Well, I've moved the difference here. I moved the decimal place once to the left, once into the negatives. So that's minus 1. And one more example, because I'm well aware of running out of time. 4 times 10 squared, of course. 10 squared we know is 100. So there we've got 400. We're going to multiply it by 4 times 10 to the power of minus 3. Well, we know 4 times 10 to the power of minus 3. We know that as 0.004. The first thing I will do is do 4 times 4, which gives us 16, or 4 times 400, which gives us 1600. And then we look to how many times have we moved the decimal place. Of course, we moved it 1, 2, 3, because it says minus 3. Okay. As a standard form, 1.6 times 10 to the power of 3. 2. 16 times 10 squared is 1600. Perfect, that's what I wanted. Okay, so let's move on now. If I flip back to my screen, we're going to go back to today's topic. As you can see on the screen, today we'll be looking at ratio. We're looking at simplifying, sharing, and finding an amount. Again, in your GCSE papers, this is going to be a crossover of foundation and higher. It really does range from as low as a GCSE level 2, excuse me, up to anything GCSE level 7, when ratio can be working with quadratics, etc. So, simplifying, sharing, and finding them out. We'll start off with simplifying. There's a couple of examples on the screen. When looking to simplify, similar, in fact, the exact same as simplifying your fractions. CF, of course, means common factor. So you'll find the common factor. For the first one, you've got 6 and 14. What is the common factor of 6 and 14? Well, 2. 2 goes into 6, 2 goes into 14, and it's the highest number. So then simply divide both numbers by the common factor. So 6 divided by 2 is 3, and 14 divided by 2 is 7. Again, simplify number 2. We've got 9 and 27. The common factor is 9. 9 divided by 9 gives us 1. 27 divided by 9 gives us 3. And then the final example, here you've got 3 ratios as opposed to 2. Same thing though, it still has to have a common factor with all 3 numbers. So the common factor of 8, 12 and 4 is 4. So we're dividing them both by 4 to give us 2, 3 and 1. Okay, so I would like to now give you some more examples. I can go to my trusty screen and I'm going to zoom in a little bit so we can see. Look at that. Okay, so simplifying 18 and 30 is the first question. Nice and easy for us. How do we simplify 18 and 30? Well, the highest common factor is 6. 6 goes into 18, 6 goes into 30. So I'm going to simply divide both left and right by 6. 18 divided by 6 is 3, and 30 divided by 6, of course, gives us 5. Okay. Over to question over here. We're going to look at simplifying 2 and 8. What number goes into 2 and 8? What's the highest common factor of 2 and 8? Of course, we know it as 2. 2 divided by 2 is 1, and 8 divided by 2 is 4. And another example over here, we're going to look to simplify 35 and 70. Now, you could work and say, well, I'm not sure. I know that 5 goes into both of them. Okay, so if we know 5 goes into both of them, then that will give us 35 divided by 5, which we could do, or we could do 70 divided by 5, but I also know that 35 goes into both of them. So that gives us 1 and 2. Now, just one trick when simplifying, make sure that you keep the order. In fact, if I just flip back to my screen, make sure that it stays 1 and 2 as opposed to swapping them over, because of course now it's a completely different question if we were to write that. Okay, so you must keep it, the lowest number starts on the left, then the lowest number must start on the left of your answer, and so on. Okay, moving on to sharing. So we're looking to share whole numbers in the ratio of something. It might not necessarily be a whole number, it might be a decimal number. But the first example here, you've got share 40 in the ratio of 4 to 6. Now, you must add up altogether the number of ratios you've got. So share 40 in the ratio of 4 and 6. I know here that I've got 10 ratios altogether. So if you want, you could say you've got 4 boys and 6 girls. So you've got 10 people altogether. I'm going to share £40, if you like, in the ratio of 4 to 6. So 40 divided by 10 would be my first piece of maths. And that would give me what one person is, how much money one person has, for example. So 40 divided by 10 gives us 4. So then 4 people must give us 16, and 6 people must give us 24. Again, we could use money, £24 in the ratio of 2 to 4, with the 6 ratios altogether. 24 divided by 6 gives us 4. 2 times 4 is 8. 4 times 4 is 16. And another example down here, you've got 75 in the ratio of 2 and 3. Of course, 75 divided by 5 would give us 15. So again, we'll multiply this ratio by 15 to give us 30, and this ratio here to give us 45. Now, how these questions can differ would, of course, be if we were to use decimals, and also if we were to use more ratio numbers. So they might have 4 or even 5 ratios, and you've got to still find the common factor between all the ratios together. Okay? Let's flip back to our screen and we could do a couple of examples on sharing. So the first one, nice and straightforward. It says share 30 in the ratio of 3 to 2. So the first piece of working out I want to show is altogether that equals 5. So my question is 30 divided by 5 to start off with, which of course gives me 6. Now, if we roll back to how the examiner would mark questions like this, they would give you an M for the method, and they would give you an A for the correct answer if the method is used. Okay, so not always do you have to show you're working out, but for a question like this, you might be given 2 marks. Therefore, it's important that you show you're working out first. 30 divided by the ratios gives us 6. So then 6 multiplied by 3 gives us 18. And 6 multiplied by 2 gives us 12. Nice and easy. A question following on from that might say, how can you check your answer? Nice and straightforward. How do we know if that's correct? What do they have to add up to? Of course, 18 and 12 equals 30. So for a bonus mark, and it's normally just for 1 mark, show how you've done your working out. Show your working out. Show how your answer is correct. Okay, and then you just put 18 plus 12, or even 30 minus 18 minus 12. Okay. Another example. Let's have a look at number 17. Then we've got share 24 in the ratio of 10 to 2. So nice and easy. 24 divided by 12 equals 2, and then therefore we're going to times 10 by 2 to give us 20, and 2 by 2 to give us 4. Over to the last question. We've got share 8 in the ratio of 2 to 6. We've got 8 divided by 8 equals 1. And then again, you multiply 1 by the 2 ratios, give you 2 and 6. 2 and 6 together equals 8. And that's what we've got given at the start. Okay, so the last question they would give you in relation to ratio on the crossover foundation and higher paper would be finding an amount. So they've given you this time one of the ratios. So in the first question, it says a number was shared in the ratio of 3 to 10. The largest share, so the 10, the value of the 10 is 15. So again, if we use boys and girls, 10 girls have £15. What was the smaller amount worth? So we would just find out what one part of the ratio is worth. So 15 divided by 10 gives us 1.5. And then multiply that 1.5 by the smaller ratio, which gives us 4.5. Again, over here, we're looking at the largest share was 30. So 30 divided by 5 is 6. 6 multiplied by 1 gives us the smaller amount. The number was shared in the ratio of 6 to 4. The smaller share was 6. So that would be 6 divided by 4, which gives us, again, 1.5. What was the larger amount? Of course, 1.5 multiplied by 6 is 9. And to finish off, we're going to do a couple of examples of finding an amount. So we'll do here, we've got this question here. It says a number was shared in the ratio 4 to 6. The smallest share was 12. So we're looking at 4 and 12. Of course, 12 divided by 4 gives us 3. So if one part is 3, then we know that 3 multiplied by 6 is 18. And this question actually says, what was the total amount shared? The smaller share was 12. The larger share was 18. Altogether, of course, we've got 30. Okay, so that's the answer to question 15. You might actually get extra marks here because they've not only asked you to work out the smaller share, but they've asked you to work out the largest share and then add them all up together, as opposed to just 2. This one is just 2 steps. A number was shared in the ratio of 5 to 7. The smaller share was 25. What was the larger amount? So we're going to 25 divided by the smaller amount, which of course gives us 5. And then we're going to multiply that by 7 to give us the larger amount, which gives us 35. Brilliant. So before we finish today, I'm going to give you obviously today's teaser, if you like. And what I want you to do is try and send in your answers to Leon and Nish, and we can shout out any answers, perhaps if you attach your names to it, if it's correct, or even if it's not, we can put it out there. But what I want to do is just summarize ratio really quickly by just saying they're the 3 questions we worked at today. So if I go back to what we've done, we're looking at simplifying, sharing, and finding an amount. And on Wednesday, we'll be looking at some more ratio on the high paper. But finally today, the question is, how many squares are there all together? So there's a picture on your screen, and I'd like you to send in your answers by telling me how many squares you can see all together. But that's all for today. Nish, if you could put it back on the screen, please.
All right, cool. Cool.
So I hope you found everything useful today. We're going to go through some different ways in which we can simplify next week, and also with the long subtraction with decimals, we might just tidy up with stuff like that for on Wednesday as well. But I hope you found everything useful today, and I'll see you on Wednesday for some more mathematics, and I'll see you tomorrow for some more PE. Cheers, guys.
Really appreciate it, Sam. Thank you so much again, buddy.
Thank you.
Enjoy your run.
Yeah, cheers. Take care. Bye.
Perfect. All right, Nish, all yours, my dear. Thank you.
All right, cool. So here is the maths task. This is just the first 3 questions. There is a whole document for you guys to do. It's not that long, and they don't seem too difficult. We do have another lesson coming up next, as ever. We will have all these videos up. They will be on Facebook and YouTube, and there is another website down here where you can catch up on everything, and all the links and resources will be there as well. You just come to join up here, if it works for me. And there is a code, it's me123. And that's all you have to do, and just fill in some details, and you'll be let straight in. And you'll be able to catch up on everything.
Magic. Thank you so much, Nish. Right, and that's all right. I get to say the very short goodbye where I say I'll see you again in 15 odd minutes.
Yeah, see you soon.
Catch you in a bit. Bye.
Bye.